let's do 312. Okay, we're going to look at possible strategies for determining whether x equals 4 is a 0 of this, of f of x. You guys, them coming at us with a 0 is I don't want to say it's a trap. It's something we need to be aware of. We want 4 to be a 0 or an x-intercept. But it's important that we know that this also means that it's x minus 4. That would be a factor. So in the equation, it should be an x minus 4, right? So please keep this in mind. Step 1, before we get started, don't let them get you. Okay, so number 1, factor f of x, or a, I mean, factor f of x to see if x plus 4 is a factor. This strategy is, it would be good if they had said x minus 4. All right, this would be a good strategy if they had chosen the correct thing as a factor. Seeing if x plus 4 is a factor tells us if negative 4 is a 0. So that's no good. Okay, next. Divide f of x by x plus 4 to see if 0 is a remainder. Again, it sounds solid. However, x plus 4 would only tell us if negative 4 is a 0. We're trying to see if positive 4 is a 0, so it's not good. I would be circling these if these were x minus 4s. Okay. Graph f of x to see if there's an x-intercept at 4. Okay, bingo. That would work. All right, if we graph it and at 4, this thing crosses the x-axis, then absolutely that would mean that 4 is a 0. That's like the definition. Okay. And then also determine whether f of 0 is 4. No. No. No, no. No, no, no. Don't let them confuse you with function notation. Please tell me what always goes inside the parentheses in function notation. I know all my students know it's x, because it's f literally of x. You see it? So why are they putting 0 in there when clearly 4 is what x is? These should be switched, all right? And how dare they? Just how dare they? Okay, let's move on. Select all the true statements about g of x equals blah, blah, blah. Oh man, I'm gonna have to check them all, aren't I? All right. Let's get to work. I gotta check them all. Okay. I'm so tired, you guys. I was saying I was tired in the last video, and I started making this one right after it. G of negative 1 equals, let's see if negative 1 cubed. Hold on. I just had a thought. My thought is, they want me to be checking factors and stuff later. Remember in the previous video, I told you the remainder theorem where you just plug it in is good if you don't have to do anything else after that. But if I'm really trying to figure out multiple different things, whether they're factors or not, I'm starting to think it'd be better if I just divided this and factored it all the way, and then I could see which one's which without doing them all. So I'm gonna start dividing, all right? And let's start with this one. Let's see if A is correct, all right? So let's do, if negative 1 is a 0, that would mean that x plus 1 would be a factor. So let's divide x plus 1 into this. And for some reason, I just want to write in black. Okay, and so we start with x cubed right here. So this is an x squared. So that multiplies to x squared. And that's x squared. And I need 7x squared, so I need 6 more x squared. And then this is 6x. You guys, if you're like, what the heck, why is she doing this so fast? It's because I've done this and explained it in detail in previous videos. So please go look at those. 6x, and then I want 4x, so it's a negative 2x. So this is a negative 2. So then this is a negative 2, which means that we have crashed and burned, you guys. We got a negative 2 here when we should have gotten a negative 12. So this is not true, okay? So now let's keep going. And let's try this one with the 1. So that would mean that x minus 1 would be a factor. So x and negative 1. An x cubed here. And that would be an x squared. And that would be a negative x squared. And then if it's a negative x squared, but I want a 7x squared, then I need an 8x squared. And so this is 8x. And so this is negative 8x. And then if that's a negative 8x, but I want a positive 4x, then I need a positive 12x. Again, if I'm doing this too fast, I've also explained this on the previous 2 videos, 2 or 3 videos. I've explained it in lots of details. I've even given you tricks on how to do it in your calculator, okay? So go back and look at those. Find them, watch the videos, learn them. Okay. 12x, that makes this a 12. That makes this a negative 12. And woohoo! Yay! Okay, not only is this true, but we have just found a way easier polynomial to deal with to figure out factors of this. So we can figure out factors of x cubed plus 7x squared plus 4x minus 12 by using this polynomial, because this polynomial is a factor of this guy. So now I have x squared plus 8x plus 12. Let's see what multiplies to 12 and adds to 8. So 6 and 2 look pretty good. So that means that this guy actually factors fully into x minus 1. That's this one that we found to be true, as well as x plus 6 and x minus 2. Okay, so now I can just answer the rest of these. Is negative 2 a 0? No, it's not. X minus 2 is a factor, meaning positive 2 is a 0, so E is okay, but B is not. Is x minus 6 a factor? No. Is x plus 6 a factor? Yes. Okay, we did it. Okay, here's a graph of this guy. Select all the true statements. Okay. Does h of x have 2 zeros? Actually, mathematically, this would be a true statement, even though technically they mean it to be not true. So let me explain. This is a 4th degree polynomial. Looking here, it has 2 x-intercepts. But a 4th degree polynomial will have 4 zeros. Some could be imaginary, okay? So that's the deal, that it definitely has 4 zeros. However, in math, if they meant that it has 2 zeros, like if it has 4 zeros, it also has 2 zeros. So I kind of want to check this box. What they should have said was h of x has exactly 2 zeros. Then that statement would be false. Okay, does h of x have non-real zeros? It absolutely does, because I can tell it has only 2 real ones, and I know it has 4 total ones, so it's got to have it's got to have exactly 2 imaginary ones. So yes, true. Is 3 a 0? Let me zoom it in here. 1, 2, 3 is absolutely a 0. Is negative 3 a 0? 1, 2, 3. Here's negative 3, and no, it's not. All right? You guys don't go switching signs of the zeros. You don't switch signs between zeros and the graph, okay? The sign switching occurs when the equation is involved, okay? So we switch the sign of a factor from the equation to get the zero. So between equation to zero or zero to equation, we change it, but not from this to the graph. You don't change that. They're saying at 3, there's a 0. You look at where 3 is, and if there is 1, there is 1. If there isn't, there isn't. Okay, let's determine all the zeros of each function. Use the clue if it helps, okay? Yeah, I'm definitely going to use the clue. Why would I not use the clue? Okay, let's find the zeros. I'm going to write it right here. And I already know one of the zeros is 4 because they told me that x minus 4 is a factor. And now if I take x minus 4 and I divide it into this, I shall get I should get a more manageable, very manageable quadratic polynomial to find more factors, to find more zeros. What multiplies to -6 and adds to 1? I'm thinking 3 and 2 are involved, all right? A -3 and a +2. That means that I have also x minus 3 and x plus 2 as factors, which means I have 3 and -2 as factors. Do you see? From equation to zeros, the signs changed, okay? All right, let's keep it going. Okay. They tell me x equals -2 is a factor of this. I don't know, you guys, can you spot it? This polynomial actually factors. I don't really need their clue. This is why, this is how I know. Is I can group these two together and these two together. And if I take a 16 out of here, I get an x plus 2. And if I take an x squared out of here, I get an x plus 2. See, when you group them together and you take out what you can, the GCF, when this thing that you get left matches, that means this polynomial factors, all right? And what it factors into is the x plus 2, and then what's in front of it. So x squared plus 16, okay? The idea there is that these two terms here, they both have an x plus 2, so I can factor that x plus 2 out, and I'll be left only with x squared plus 16. Another way you could factor this is to go to the box at this point and just put x cubed, 2x squared, 16x, and 32 in the box, and then start taking things out. So here you could take out an x, here you could take out a 2, here you could take out an x squared, here you could take out a 16. So you see x plus 2 and x squared plus 16. Okay. And then you'll see, okay, -2 is a 0 because of that. And then this means that plus or minus 4i is also a 0. Because I've done a bazillion of these on the previous videos, all right? You set the x squared plus 16 equal to 0 and you solve it. This is what you'll get. Give it a shot. If not, go back, watch older videos, find similar problems. So here's our zeros, -2 and plus or minus 4i. Okay, and now here I am. See, this is a cubic polynomial, but it's not going to work out like this, you guys. You can tell. Take a look, all right? I'm not going to be able to factor something out of 12 and 10 and then end up with like a 7. It's not going to go like that one did. So in this one, I can't factor like I did this one. On this one, what I can do is look at their clue, which is x-intercept at -5. which means factor of x plus 5. So then I'll divide x cubed, x plus 5, x squared, 5x squared. I'm getting sleepy. 2x squared, 2x, 10x, 2x, 2, 10. All right, you guys, I'm doing it like this on purpose. I want you to do it yourselves, okay? I want you to do it yourselves. I'm hoping that all the explaining I've done earlier in the other videos is giving you the tools to do it yourself, okay? So do it yourself and then look at mine and see if you got the same thing. But please don't continue to rely on me to be able to do it. That's not going to help you for the test. And now here I am with this situation. And I swear we did this exact problem in class. It was in that game show they had. Okay. You guys, a 2 and a 2, that's a factoring death sentence, all right? This does not factor. So for my zeros right now, all I have is the -5 that they gave me. I have this function right here, x squared plus 2x plus 2. But I can try forever. I'll never find two numbers that multiply to 2 and add to 2. It's just 2 and 1. It's not going to work, all right? So we got to go to the quadratic formula here, all right? So x equals -b plus or minus the square root b squared minus 4ac all divided by 2a. And then we plug everybody in. And I swear to God, if it's 1 plus or minus I, let's see, -2. Okay, please remember A is 1, B is 2, C is 2, okay? 1, 2, 2. Okay, plus or minus the square root of B squared. Okay, it's going to be -1 plus or minus I. B squared is 4 minus 4 times 1 times C, which is 2, all divided by 2a, which is 2. So this becomes, this is x equals, this is -2 plus or minus, this is 4 minus 8, which is -4 inside the radical, all divided by 2. Which is -2 plus or minus 2i divided by 2, which is, okay, go cancel, guys. 2 goes into 2 once, 2 goes into this 2 once. This becomes -1 plus or minus I. These are two more zeros, all right? Okay, oh my God, we're still doing this. Okay, determine all the zeros of this function. Cool. Can you see it, you guys? Can you see that if you group these and you group these, your parentheses will come out the same? Take a -1 out of those two, and you'll get x plus 5. Take an x squared out of these two, and you'll get x plus 5. Then take the x plus 5 out of these two, and you'll get x plus 5 times x squared minus 1. Or go to the box, the 2 by 2 box, and put x cubed, 5x squared, -x, -5, and take stuff out. All right, either way you get this. And this right here is the difference of squares. X squared minus 1, that factors to x plus 1 and x minus 1. So here we go, all the zeros, you got it. -5 is 1, -1 is 1, +1 is the last one. Okay, here I am. This is a closet quadratic, all right, because it's an exponent, it's half that exponent, it's nothing. And I can, as long as I find two numbers and multiply to 8 and add to -6, so like -4, -2, I'm set, all right? But except this time, it's x squared that goes in. So this is x squared minus 4 and x squared minus 2. All right, let's go. This one factors to x plus 2, x minus 2. So 2 and -2 are two zeros. And then this guy will get me rad 2 and negative rad 2. I'm not going to do it. I'm not going to do it. Solve that. Okay. Fill in the blanks to write a function that can be solved without any clues. Then determine all 4 of the zeros. Okay. 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 Why don't we just take the one they gave us? That one was solved with no clues, and then the 4 zeros. Oh my god, I just want to do this. -6 and 8, and do 2, -2, √2, and -√2. It is definitely low-key cheating. So let's be good, let's be good, let's be good. Just pick some numbers that factor, you guys. Like pick something like, let's go with like a, I don't know, a 4. Oh, what happened? My iPad is tired of this. Oh, no, I don't want that. Okay, here we go. I was going to pick a 4. And then say like 4 and 1 multiply to make 4. And then they add to make 5. So I could put like 5 here. And I could put 4 here. And it would factor. And you could do whatever combo you want. Just make sure you put stuff in the right places. And then this would factor into x squared plus 4 and x squared plus 1. And this would give me plus or minus 2i. And this would give me plus or minus not 2, just regular I. If you tweak these to make them negative, negative, and negative, then these would come out to not be imaginary, and they would be positive 2, -2, positive 1, -1. But who cares? You have infinite possibilities here. Okay. Oh my god, I don't want to do the spiral review. What's going on? Here are the characteristics of this polynomial. What could it be? This is important, you guys, for your test, so I will do it. I'll do it. Here are the characteristics for a polynomial p of x. Okay, what are these characteristics telling me? This right here is telling me the end behavior. It's telling me that on the left side, it goes down. And that on the right side, it also goes down. So this tells me that it's negative. And it also tells me that it's even, all right? It has a 0 at 1. That means that x minus 1 is a factor, all right? It has 2 unique x-intercepts. That means it has some other factor, all right? Okay, now let's go. What could this equation be? Well, it can't be c because c is positive, and I know mine is negative, all right? The rest of these are even. Bless their hearts for not letting me eliminate anymore based on this knowledge. And now, what else? I need x minus 1 to be there because there's a 0. So this guy is out. He doesn't even have x minus 1. And now between a and d, if it has 2 unique x-intercepts, it would have some other factor like d does, but a does not. So that's the one. Okay, guys, good luck. Peace out. I am done.